So in this case, I want us to consider another revision exercise where we need to actually focus with our geometry of straight lines and also the properties of the shapes that we have in our syllabus. We are given in the diagram, that is in this whole diagram that we have, BC is parallel to GK. That is the side BC and these of GK, they are parallel. That is the only part that we have out of our diagram where we are given, in this case, where we've got a triangle and also the indications of the lines which are equal. We have got angle E3, 60 degrees, all right? That is at point E. Here, that is, we've got E3, which is 60 degrees, and also E5, which is 30 degrees. GE bisects. What is to bisect? You are given an angle like this. A line which bisects an angle divides this angle into two equal parts. So we are given that GE, meaning to say this angle, this line, GE, bisects HEF. HEF is divided into two. That's the indication that we are seeing here. It is divided into two equal parts. All right. Also, we are given BE is equal to BD. From B to E and B to D, we are given that these are equal, and we can see that indication there. So meaning to say the angles there, E4 and D1 must be equal. Remember, concept of angles opposite equal sides. So it means angle E4 is equal to angle D1. We are supposed to know this from our triangle. So this is what you're given and what you can also tell. So the first question, number one, was to show that BE is perpendicular to GK. This is perpendicular. That means from B to E, this is BE, like this. This BE is perpendicular to GK. That is from G to K. Remember, this is where K is. GK like this. They must be at 90 degrees. Perpendicular, meaning to say they must be at 90 degrees. They must be at 90 degrees. That is to be perpendicular. So how can we prove this? All right. How can we show that? We just need to calculate, is this angle 90 degrees, the whole of E, which is the whole of E4 and E5. If you add angle E4 plus angle E5, you must obtain 90 degrees. Or if you add angle E1, E2, and E3 together, if you add those three, angle E1 plus angle E2 plus angle E3, you must obtain 90 degrees for us to say that is perpendicular. This one, it must just be, okay, GK. So we just need this one, G2 and E3. E2 and E3. This one, remove this E2 and E3 only here. If these two here, remember this is your straight line here, like this. And this is your other line, this one, BE like this. So you're considering these two, E2 and E3. So if these two can add up to 90, or E4 and E5, that is what you need to prove. All right. So which one that we can prove or that we can work with, that is now we have to consider whatever that you are given inside of this shape. All right. We have got an angle of 30 degrees so far, and the 30 degrees, the 60, this one that we have at this point. So far, this is what we have. Is there anything that we can use on this straight line We cannot because we do not know this angle. We just know that it is equal to this angle. Remember that. But we do not know that. Okay, just leave it for now. Let's move on to the parallel lines. We have got lines that are parallel. Are these lines going to help us to find any angle inside? Is it inside of the triangle or not? Are they going to help us? All right. These parallel lines, look, guys, we are forming a Z, the alternate angle. We are going to find the angle at C. If this is 30 degrees, then that means this is going to be 30 degrees. Angle C is equal to angle E5, which is 30 degrees. Those are alternate angles. Remember your alternate angles where you form a Z. This is what you are given or what you can work with for now. Okay? And is it going to help us? It's a question. Remember, guys, this is a question that you need to ask yourself. Is it going to help us to find whatever that we need? All right. At this moment, we can see that 30 is also limited. From our parallel lines concept, the 30 degrees is limited. How? Because this cannot be related to this angle. Neither one of these ones. So there, we are also limited. Okay, we have got the condition of the vertically opposite angles. Okay, remember, vertically opposite angles. Are they going to work? So like I said before, it's a trial and error. Trial and error. Let's see here. We have got vertically opposite angles, this line. Oh, let me just use this one that can be clear. There we have got a line and a line extended like this from H passing E to D like this. This one is a straight line. So we are talking of what? The vertically opposite angles. Vertically opposite angles, meaning to say these two angles must be equal. So the angle at E5 and the angle E1, they are equal, vertically opposite angles, all right? So there we're going to consider E1 to be equal to E5. Let's see if it's going to help us, which is also 30 degrees. So this is 30 degrees, okay? Remember that E1 is equal to E2 from the concept that this one, it bisects, GE bisects this angle HEF. It is divided into two equal parts. So E1 and E2, they are supposed to be equal. That's 30 degrees. So guys, we are almost on our answer there because remember what we said, we need to prove that either of these must add up to 90 degrees. So by knowing that E2 is 30 and E3 is 60, let's see if this is going to give us, because that is what we need there. Angle E2 plus angle E3. Angle E2, we calculated E2, that is 30 degrees, plus E3, that is 60 degrees. If you add these two angles, you are obtaining 90 degrees here. There is a 90 degrees. What does it mean? It means these two lines, they are perpendicular. So therefore, we can say these two, they are perpendicular. BE is perpendicular to GK. So meaning to say this first statement here was not going to be necessary. We're going to start from this one. Okay? So it's a trial and error. So this is what we can use to prove that these two, they are perpendicular. They are at 90 degrees. That is perpendicular at 90 degrees. So let's consider another part, number 2, show that triangle BED is equilateral. All right, a triangle is equilateral. And remember, an equilateral triangle, all sides are equal, or you can use the interior angle is 60 degrees. Remember, each angle in an equilateral triangle will be 60 degrees from 180 degrees divided by 3. That will be 60 degrees. So each angle is 60, 60, 60. So BED, that is, let's see, from B to E to D, this one. This is the triangle that we are talking about here. We need to prove that this triangle is equilateral. So we're just going to work with the angles there. All right, let's work with the angles. Remember, we have got a straight line here. So we can calculate angle E4. Let's start with angle E4. Angles on a straight line, they add up to 180, or you can use the concept that we say these two are perpendicular. So to find E4, there are so many ways. You can use the perpendicular concept because they are at 90 degrees. So E4, you can simply subtract that 30 degrees from 90 degrees. That's 90 minus 30 degrees, which is 60 degrees, because we say they are perpendicular. So E4 is going to be 60 degrees. Or you could have calculated E4 from angles on a straight line. We consider a straight line, we subtract all these angles on a straight line. We subtract the 30 degrees, which is E2. We subtract the 60 degrees, which is E3. We also subtract the 30 degrees on the other hand. That is removing the angles that are on a straight line. That was still going to give us the same 60 degrees. There are so many ways that you could have calculated this. Remember that E4 and D1, they are equal. I stated that. So by finding this, we are finding angle D1 at the same time. Remember, D1 is equal to angle E4. Angle E4, which is equal to angle 60 degrees. Remember, this from the sides which are equal, we talk of what? Angles opposite. Angles opposite what? Equal sides. Equal sides. So these are supposed to be equal. So thus we can also calculate B2, but by having this 60-60 angles inside of a triangle. So that's angle B2 can be calculated. Since we have got these two angles, we can remove from 180 degrees angles inside of a triangle. You subtract the 60 at E4. You also subtract the 60 at D1. This was going to give us 60 degrees. So as we can see, all the angles inside this triangle are equal. So thus, in this case, we can conclude to say, therefore, triangle BED is equilateral. That is the whole idea there. These angles, all of these angles are equal. That is, all angles are equal. All angles are equal. All interior angles, they are equal. We are using the angles there. Number 3, you need to show that EF is parallel to DB. All right, EF is parallel to DB. From E to F, this one, EF, and this DB, they are parallel. In order for you to show that you can, you remember, you need to prove that the two lines are parallel. So to prove that the two lines are parallel, all right, let me explain it here. This is what you just need to prove that two lines are parallel. You just need any one of the conditions that parallel lines give. Remember, from parallel lines, that's where we talk of the co-interior angles, which give a C, the corresponding angles, which gives us an F, the alternate angle. As long you can prove from one of these, it means those lines are parallel. So in this case, if you were to check properly here, you are going to see that we are forming a Z because that is 60 degrees there. If these two angles can be equal, definitely these two lines are parallel. There's no way that this angle and this angle will be equal. Guys, there's no way. And that is exactly what we can see there. Angle E3, remember this was E3. Angle E3 is equal to angle B2, which is equal to 60 degrees. Thus, therefore, these two lines are parallel. So therefore, EF is parallel to DB. Why? We are talking of the alternate angles. Those are referred to as alternate angles. Remember that alternate angles are equal, the ones which form a Z. So you prove from any one condition which is applicable. So there, the part of alternate angles was going to be best. I don't know if you've got any other way to prove that as long it is geometrically true. Calculate the size of angle C. Angle C. All right. So actually angle C, we obtained this previously. Remember, we told that these two lines are parallel. So we just have to take this condition from our parallel lines. That was going to be 30 degrees. That's why in the first place I said do not consider this. So already we answered this one. Angle C is 30 degrees. Then after that, we need to show that on number 5, BD is equal to DC. We need to show that BD, that is from B to D, this one, and DC. All right, that is DC. All right, this one, DC. As long you are to prove that two sides are equal, it's all about the angles that you must work with. Remember the concept of the angles, that if the angles are equal, if this angle B1 and C are equal, the sides opposite must be equal. So whatever that we need to prove here on question number 5 about these two sides, BD and DC, it must be from the angles. As long you can prove that angle B1 is equal to angle C, as long you can prove this, we are done. So we calculated that, or we stated that angle C is equal to 30 degrees. We have this. All right. Let's see, let's calculate angle B1. If angle B1 can be 30 degrees, then we are done. Where can we obtain angle B1? From which concept that we can use? All right, remember these lines, they are parallel. And from being parallel, we can see that we are having C angles, co-interior angles there, where we are forming a C. We talk of what? Co-interior angles, which add up to 180 degrees. So it means that to obtain angle B1, we can simply calculate this from angle B1 plus the 60 degrees here, this whole angle. Remember the C here, this is our C here, from K to E, like this, going to C, like this one. So we are referring to the whole of this B, meaning to say B1 and B2. So that's B1 plus 60 degrees. Plus this whole of angle E, which is E4 and E5. E4 and E5. Remember there we added E4 and E5, the 60 and the 30 was going to give us 90 degrees. It must give us 180 degrees. These are co-interior angles. Remember, these are parallel lines. So you're talking of what? Co-interior angles. So we can calculate B1 from there. Simply remove these from 180 degrees. So that's 180 minus the 60 and the 90. There we subtract 60, we subtract 90. That was going to give us angle B1, which is 30 degrees. So thus angle B1 is 30 degrees. So there is no way that angle B1 will be equal to angle C. There is no way that these two angles are equal. It shows us that these two sides are also equal. That means the side BD is equal to the side CD or DC. There is no way. Because of these angles, the sides opposite these angles must be equal. So these are sides opposite equal angles. So we are talking about sides opposite equal angles. Remember, it can be from angles opposite equal sides. This time we are proving about sides. So it must be sides opposite what? Equal angles. So that's it. We have got shown that these two sides are equal. So that was our question number 5 of this question. So you need to actually understand your questions. All right. On another question you are given in a triangle DEF. That's we are given a triangle DEF in this case. That is, let's see what we are given here. That is DEF from D to E to F, the whole of this triangle there. All right, so this is the point E and this is the point F. So there we are given something that is GE is GH is parallel to, let me just try reduce so that you can see it here. We are given that these two sides, they are parallel, GH and EF. That is these sides and EF, they are parallel. Then we are also given DGKH. The whole of this is a kite. All right, from D to G to K to H, we are given a kite. We must also consider the properties of a kite. What are the properties that we understand or that we do know about a kite? We do understand that in a kite, the adjacent sides, they are equal. Adjacent sides are equal. And we are going to have a condition between these adjacent sides that these two angles will be equal. These two angles opposite will be equal. Not this one and this one, no. But these two will be equal. So we shall see if any of these can apply. All right, so with this, we are also given the angle G2, 40 degrees, the 50 at angle E, the angle K3, which is X, and angle D, which is Y in that case. And with this, you are asked to calculate with the reasons the value of X and Y. All right, let's see what we can do. What is it that we can use in this case to find X and Y? All right, let's start with our X, whatever part that you can use. There we have got the parallel sides. We've got these two sides which are parallel. So far from these parallel sides, this is what we can conclude, that angle H2 and this K3, they are equal. We are forming a Z, alternate angles. So this is going to be X, same as this K3. That is what we just understand or what we know about these two. All right. So with this, we are still limited with this information that we are having. We are still limited because we do not have this angle K2. All right. We do not have this angle K2. We can have it in terms of Y, but that means we're going to have another complicated part to work with. So we can just leave it like that. Let's see another part that we can use to find our X. All right, we have got a 40 degrees. Is there anything that we can use from these 40 degrees? That is what you have to ask your question. You have to ask yourself this. There's nothing. Just leave it like that. What about the 50 degrees? All right. These two lines, we are forming co-interior angles, the C. Meaning to say that angle G3 can be calculated. We can calculate angle G3 from there. Remember, co-interior angles, they add up to 180 degrees. So we are going to subtract the 50 degrees and the 40 degrees where we form a C like this, a C. So a C, it's part of G2, G3, and the 50 degrees. They are part of the 180 degrees. So we subtract also the 40 degrees. Thus, we are obtaining angle G3 from these two angles that we are having. And that was going to be 90 degrees, okay? That's 90 degrees. So G3 is 90 degrees, meaning to say That's a right angle there. All right. Anyways, let's just write it. It's 90 degrees. So by knowing that G3 is 90 degrees, it means we can obtain the value of K. Actually, we could have just taken this K, guys. All right, there was actually no need here, guys. We could have just taken this K, which is fine. It's good for your revisions. You could have just taken this K1 like this, angles that form a Z, alternate angles from our parallel lines. So K1 is equal to 40 degrees. We could have just taken that one straight like that. So that is 40 degrees, which is equal to G2. Those are alternate angles. Since GH is parallel to EF, these two lines, they are parallel, remember? So having 40 degrees, how is it going to help us to find X? This is where we are. All right. Let's consider where we are. We have got this 40 degrees and we've got X here. We can use this concept that this K2, we can have it in terms of X. Remember angles that are on a straight line, or we can use the angles inside of a triangle. All right. Remember that angles inside of a triangle, they are going to add up to 180 degrees. So meaning to say this could be calculated from 180 degrees about angles inside of a triangle or angles on a straight line. So this is what I want you to see. Angle K2 is equal to 180 degrees minus, you subtract the 40 degrees, you subtract the angle X, this one that we are having. All right. Thus, we are talking about angles on a straight line. So these are angles on a straight line. You're considering a straight line. So sometimes it's necessary to have all these steps. Let's subtract 180 minus 40. These two are like terms. That was going to be 140 degrees minus X. So we are going to have 180 degrees minus X because the X is still there. So this is 140 degrees minus X like this. All right. So still we're going to have something that will neutralize our question here, which will limit us to find the X. All right. So with this information, how can we obtain or how can we solve for the same X that we are given in this case? Guys, if you are to note, we are going to see that this here from our parallel lines is the same concept that we are having from this other hand. All right, I want you to see from this hand here, because we are told something about a triangle. All right. All right, remember these two sides are equal here. Adjacent sides. So these two can easily be equated. All right, this was actually not even necessary to have this, guys. This was not even necessary. This one. This was not even necessary. This was a straightforward here. We can simply take it from this one. Remember that these two sides are equal. So simply, we can equate the X and the 40 degrees. All right. That means sides that are opposite. Okay. So that will be 40 degrees. If we have got sides that are equal, the angles opposite these sides must be equal. Remember the properties of a kite, and I also talked about this before here, properties of a kite. So we could have just applied that case in this case to be 40, meaning to say, if this is 40 degrees here, 140 minus 40 is what? Remember, this is 180, 140 minus X here. 140 minus X. It means we've got 140 minus 40 degrees, which is 100 degrees. So it means this is 100 degrees. And if you can check angles inside of a triangle, they add up to 180. And that is exactly what we want. So X was simply 40 degrees, guys. Here, we could have stated that long time from this concept, this is 40 degrees. All right. since we are using the properties of a kite, that adjacent sides of a kite, they will be equal. This side is equal to this side. It was a straightforward. All right, then to calculate the value of y, we can use the concept. Remember, we have already the wall of this part is 140 degrees minus 40, which I said is 100 degrees. So it means K2 is 100 degrees, all right? If K2 is 100 degrees, it's going to help us to calculate angle Y. If K2 is 100 degrees, we can calculate Y because we do understand that these ones must add up to 180 degrees, okay? Remember, these two opposite, the adjacent, the ones that are in between the adjacent, they are going to be equal. They are going to be equal, but these opposite ones, you'll see that you're going to obtain 180 degrees. All right, what is the concept about that you can use? All right, these are properties of a kite that you can simply apply. You're applying the properties of a kite. Or you can use this concept if you do not want, or if you do not understand that. 90 degrees here, remember we said there's a 90 degrees here. So it means here we also have a 90 degrees that is remaining, and 90 degrees that is remaining. So definitely these two angles must add up to 180. Why? Angles inside of a quadrilateral add up to 360. So 360 minus 90 minus 90, you're going to obtain 180. So all this you are just supposed to understand, guys. If it is at 90 degrees, just subtract that from 180 degrees. So that's 180 minus 100 degrees. So that was going to be minus the 100 degrees at K. You are subtracting angle K. All right, that was going to be 80 degrees. So meaning to say Y there is 80 degrees. Just subtract that from 180 from the concept that I was explaining. All right, number 2, we are now asked to show that GK is perpendicular to DE. That is G to K. All right, GK, this one, is perpendicular to DE. It is at 90 degrees. Already we calculated this, guys, from the angles inside of a triangle from that concept that I was explaining before. So we already saw that here G3 is 90 degrees. So meaning to say these two, they'll be equal. They'll be perpendicular. I mean, G3 is equal to 90 degrees. You're going to use this calculation. We calculated this before. So that means, therefore, these two are perpendicular. GK is perpendicular to DE. Being perpendicular, that is at 90 degrees, it is at 90 degrees at right angles. That is being what? Perpendicular. So already we stated this, or we calculated this before. It is just a continuation. So like I said, revise as much as you can in your geometry. As you can see, the first part here, to answer for X, it was not necessary just finding K1. After having K1, you can have your X, then you can have your K2, you have your Y like that. You're done. So do revise as much questions as you can.